Welcome back. All right, so if you made it through the recursive version, or if you just watched the solution, which in itself was a bit of a battle to make it through, we're now going to do the same thing iteratively. And I do recommend doing both of these because I think it helps solidify, for a lot of people, one, graph traversal, but two, recursion and iterative solutions in general, and sort of how they relate and how they're connected. So what we do, instead of using the call stack to help manage our state, to keep track of, where we're going and where we've come from, we're going to just use a stack itself. So in JavaScript, I'm going to just use an array to do that. You could write your own stack class again and take advantage of that. But for us, conceptually, and just to make it short, we'll just use an array. So DFS iterative, here's the basic pseudocode, and then I have the more in-depth version. So we'll make a stack called S, which will be an array, starts empty. And we push the starting node, the vertex will start from A, probably, onto the stack. That's the first thing we want to do. Then we have a loop. While S is not empty, while there's something in the stack, we're going to pop something off of it, call that vertex. And then we're going to check if it's not discovered, meaning if we haven't visited yet, visit it, add it to our list, label it as discovered, and then for each of its neighbors, push them onto the stack. So the first time through with A, well, it hasn't been visited because we just started. So we visit it, and then we mark it as visited. And then we look at A's neighbors, which if we're using the same graph, are B and D. And once again, I do recommend you set up the exact same graph just to make it easier to follow along. All right, so that's the basics of it. I'll show you the more in-depth version in just a moment. You use a stack. That stack maintains sort of the order of things that you've been to, but also where you need to go back to and visit other neighbors, because the way depth first works, we're going to go all the way down one path, and then we need to go back and visit the other siblings. Not quite siblings, but the other branches. All right, so here's the more detailed pseudocode. Write your function. I'm going to call mine depth first iterative, and it should accept a starting node. I'll just call it start. Then create a stack. An empty array is what I'm going to use, but again, it's up to you how you want to implement that, just to keep track of vertices. Create a list or an array to store the end result. I'll call mine result. It should begin as an empty array. Then create an empty object to store visited vertices. Or you could do it with an array, but we need a way to keep track of what we've already visited so that we don't try and visit them again and get stuck in a loop. And then we need to add the starting vertex to the stack and mark it as visited. So we need to have something in there so that we can add this loop while the stack has something in it. Otherwise, if we tried to just wait to add it inside the loop, it would never run because the stack starts as empty. So we want to put the start at the beginning. We want to put that in the stack. Okay, so as long as the stack is not empty, I would just check as long as it has a length, pop the next vertex from it. If it hasn't been visited yet, mark it as visited, add it to the results list, and push all of its neighbors onto the stack. So I'm just going to use another for each, but rather than recursively calling another function, we're just going to push them onto the stack and use that stack. Rather than the call stack to keep track of where we are, I'm going to use just an array to do it. And then at the very end, we need to return the result array. So a quick note, you'll actually end up with a different order than what we did in the recursive solution. It still will be depth first, but it's a different order. And we'll talk about why that is in just a bit in the solution video.